So, how many of you got 10 contacts now? Right? I know I do. I know there were some people, they were smart, they were like, oh, I'll ask him. So you have a table. So now, I'm gonna keep us moving along to talk about innovation and disruption here. And now I'd like to bring up Jesus Mantas from IBM, right, to talk about AI hardware to drive innovation. Where are you? There we go.
Hi, Gene. Where's Miriam? I am here. I just want for the record, I'm Jesus Mantas, I am here. She didn't see me, but I didn't know that she was gonna be looking for me. I have 3 phenomenal panelists with me today that they're gonna come up here in a second. One of them is being mic'd. But I'm very proud of something. It has been, what, like an hour and we haven't talked about AI? This is like a new record this year. So I feel very proud that we have actually prioritized human intelligence as opposed to artificial intelligence this morning. So a lot of what we do in high tech is to make sure that we don't forget that what moves the world is, for the most part, the ingenuity of the human intelligence. So let me get the panelists one at a time here. Let me start with Anne Villegas, Director of Intelligent Collaboration, Commercial Architecture, HP Inc. Give a hand. Good morning. Prasanna Pense, he's the Global Director of AI Strategy at ThoughtWorks. And last, but I don't think we could actually talk about AI hardware without having this company represented. So Chris Nelson, Director of LLM Gen AI Go-to-Market Strategy, NVIDIA. Okay, so here's what we're gonna do. Start preparing your questions because we're gonna have a conversation, a few topics that I noted here for about 20 minutes, but then I really actually wanna get you microphones and make sure that you have an opportunity to ask some questions to the great panel. I love to start with the end. And that means if there is only one thing that this audience is gonna remember of this session, let's say it now, get out of the way, and then we can talk about anything else, right? So, and the one thing that you would like them to remember in the topic.
I would say that everyone can feel empowered and excited at this pivotal time in our industry. Right? This is the opportunity for us. We don't have many pivotal changes in each of our lifetimes, but this is it, right? This is it for us.
So feel empowered, don't feel afraid, I guess.
Right, and own up, take the opportunity to innovate and to help lead your communities, your teams, your companies through this time.
Adopt AI, empower, not afraid.
Yep.
Prasanna, what's the one thing that you want everybody to remember?
To me, it's 2 sides of the coin. On one hand, it is you ain't seen nothing yet. Like the speed at which things are changing is going to keep accelerating. On the other hand, the path to making it real is there are some challenges ahead that we need to make, that we all need to work together to solve.
So whatever whatever excitement you
think
you've seen, you haven't seen anything yet. So if you think you've missed it, don't worry because you get to catch up on the next generation. So that's pretty hopeful for me. Chris, what's the one thing you want everybody here to remember?
Yeah, I'll kind of add to what has already been said. I think we see this moment as a revolution, right? In the same way that we've seen the internal combustion engine, the introduction of the internet, the introduction of AI, and it's in the way that everything will change, and there's infinite opportunity to leverage that in any variety of ways.
Yeah, and I think, and I'm going to stay with you for a second. So I'm going to double click on those 3 points just to make sure that we cover it. But everybody not everybody. I mean, the majority of this room has experience in some form AI as software. And we just don't worry how that things happen. You go to ChatGPT and it gives you an answer. You go to any other, Perplexity or any other model and it gives you an answer. And we have, for the last decade and a half, we have done such a great job virtualizing hardware that most people here is like, well, why do I need to learn about hardware? Like, I just type and stuff happens, and that all runs somewhere in the cloud, and why do I need to worry about that? So I'm going to start with NVIDIA, and just to ground the room. So Chris's company, NVIDIA, in 2021 had roughly 15 billion of revenue. You're on a run rate of 100 billion and accelerating in 3 years. So that means somehow this thing of hardware for AI must not be as easy as everybody thinks, because otherwise everybody would be kind of like taking a portion of those 85 billions of new revenue you've created in 3 years. You've kind of like multiplied your company by 4 times, 5 times. Why is it so hard? Like, what is it that it makes NVIDIA have such a grip on AI hardware right now?
It's a good question, and the story's been told many times. I probably won't do it justice, nor would I try here. Much smarter people can explain the details, but in maybe just a 50,000 kind of foot level, the convergence of a few things coming together in this moment were key. If you look back at NVIDIA's history, back to when we started as a computer graphics company, and so some of the original engineering has always been hardware and software together, but some of the original engineering was for a chip or a set of chips, computer chips, processors, that could do a whole bunch of calculations in parallel. They all have to happen at the same time. If you think of a screen, of a TV or something like that, the higher the resolution, the better the display. That's possible when all of the individual points on the screen can be calculated at the same time and displayed more quickly. So that was history. And then in parallel to some of that history was the mathematics and the theory and the research that was happening in the way what now is artificial intelligence, deep neural networks and these other things. Those two things then came together a number of years ago, where it was realized that the same set of parallel mathematics that was useful for accelerating graphics is exactly the same type of math that's leveraged to do all of the underlying work that powers AI. So that convergence of things was fortunate, maybe a bit foreseen, and has been leveraged for this explosion in the last few years.
Why is it so hard to replicate? Like, I mean, it's not like there is no other company that does semiconductors. Is it the combination of hardware and software? Is it the ecosystem? Is it some like better way to create the chip? Is it the logic? Like, when a market explodes like that market, you figure everybody's going after it. Intel, AMD, like everybody that produces chip is like, they would wanna take a portion of your cake, and yet it's not that easy. So what makes it unique?
Yeah, I think you offer 2 or 3 places in a layer or in a stack. I think there's certainly some of all of that. NVIDIA's strategies, long before, I've been there for 4 years via an acquisition, but long before I was a part of it, NVIDIA's strategy has been to develop a platform and an ecosystem around that hardware. So as I said, we have far more software engineers than we do hardware engineers, and their job on a day-to-day basis is to develop the layers above the hardware to make it accessible to everyone who's doing cancer research, to oil and gas application space, to whatever industry vertical you choose. That application sits on top of a software layer. And so that combination of the most capable computer chips GPUs, right, that are in the world today, and the optimization of 30, 40 years of experience of software on top of that. I think that combination has enabled it in a way that's been good for us over the last few years.
And that's, I mean, kind of going back to what the one thing you wanted the audience to remember is that thing that NVIDIA may sell parts because clients want parts, but NVIDIA is not a parts company. NVIDIA's success is the fact that you have combined, I'm going to abuse the analogy, you've become the Apple of AI GPUs, where you're combining the hardware, the software, and the ecosystem in such a unique way that anybody just doing one of those things have a very hard time coming up with a better solution, right?
I think that's true. I think you can look at, you see us in the very front end of research in a variety of places, and most often, Jensen, our CEO, will describe that we will build something kind of bottom to top in a particular vertical, not to try and compete in that space, but to understand the solution and push it forward with the leaders in that space, and then we disaggregate it and make all of the components available at the various levels as well.
Yeah, and just, again, full disclosure, IBM is indeed a partner of NVIDIA, and IBM Consulting is actually a partner with NVIDIA. I don't think we get down to the chip level of pretty much anything, but it's that fact that NVIDIA focuses in the actual solution to a business problem that makes it relevant for us and any of our competitors in consulting to actually have a relationship with you, which is what your day job is to actually develop that. Okay, let's get to Prasanna. So you said we ain't seen anything yet. Can you give us a glimpse of what is it to see in the future? Like what are the things that you have seen that they're coming up that excites you, they have real value, and you think everybody in the room needs to be aware this is coming, brace yourselves?
Yeah, I think it's already come to some extent. So if you had asked me, actually I was on a podcast about a year ago, and they were talking about similar question about what's coming up in next. I said one of the challenges is high-speed memory access and high bandwidth memory access, especially across multiple GPUs, is kind of a big problem to be able to build really big models.
Explain the problem. Like, some people may hear you say that, but don't understand. What is the problem of high speed, high throughput?
Yeah, so between the GPU and the memory, if the way Chris described it, GPU is solving multiple problems in parallel. A lot of problems you can't break up into kind of different places. So all of that needs to, each problem solution needs to come back into the whole together at very frequently. And in order to do that, you need one big pool of memory that's accessible from multiple GPU cores.
Right.
And the bandwidth to that and the size of that memory pool is a bottleneck to create bigger and bigger models. Because essentially distributed models, as of today, are less good than the really big models in certain cases. So, but the GB200 kind of makes a big leap in that part. But now I think the shift is getting into things like, okay, fine, you built this really big model. How do you deal with it at the edge? What does edge-based model from an inference or execution of the model look like? So a lot of things happening at the edge, smarter and smarter edge devices coming out across the market. And the other aspect is people are kind of looking at the deep neural network pattern in software and saying, can we create chips specifically for deep neural networks? So what's known in the industry as neuromorphic chips. That's one area that I'm optimistic about. But with anything in the semiconductor industry, it's going to take a while before these things become real, because it's not that easy to, like in software, you think of an idea, tomorrow you can put it live. It's not so easy to make all of these things physically.
So I think to your point is for the most part, the majority of workloads of AI today are kind of being, well, the training clearly is happening on a data center, and then the inference, right, when you're asking, is mostly also happening on a data center. And what you're saying is, well, that we're going to a future where we're going to have the two modalities coexisting,
edge, meaning on the device, you're going to have some portion of the AI workload, and then on the data center, you're going to have some portion of the AI workload, and those two things are going to evolve. When I think of edge, and to your point, it's going to take time unless you have a fantastic marketing machine like Apple, and then you just call it M4, and you assume that has happened already. So how much of that is marketing, and how much is that, I mean, they show you the chip, and they call it neural, and they tell all those things, and for people like me, it's like, oh, that sounds good to me. How much of that is a peek into what you're saying is coming, and how much of that is like really clever marketing?
I know some engineers at companies like Apple and other places, and the sleepless nights and weekends that they spend, I can say it's not just marketing. Like there's a lot of physics that's gone into it, a lot of math that's gone into it. And yeah, certainly the way, like sometimes technology is ahead of where it can be used. So there's a need for being able to communicate it in a way that is easier to understand. But actually, to me, the capabilities that are being built in the new M4 chip or in some of the new products coming out, the use will catch up soon. So I think there is a lot of engineering that's gone in already.
So like sometimes clever marketing actually does talk about like real things, right?
Yes.
So I'm looking forward to figure out what to do with the M4 in my new iPad. I have no idea what to do, so you can give me some, can give some of us some clues as what to do with that chip.
When I was looking at the specs, the 16 GB memory on the new iPad Pro was not that interesting. What it's going to allow once it becomes in the MacBook Pro is going to be much larger unified memory spaces. So I think that will be much more interesting than the iPad
Okay,
Pro.
so that's another reason for an upgrade. You see, it's still clever marketing, right? Anne, you spend a lot of your day job with users, with people, with how they interact with technology. So you get to see a lot of these use cases and the adoption. And I mean, obviously, you have to use some kind of hardware. It doesn't need to be a data center. It could be a workstation. It could be anything else. That was the point that you said. You want everybody here to feel empowered, to really engage, use the technology, distribute the technology, be part of this revolution. Tell us a little bit about the use cases that you're seeing. Like how are you seeing around you? Who is doing that really well, and what can we learn from that?
Yeah, I think for us, we've been on this journey for about 5 to 6 years, right? Trying to bring AI into the PC experience. And so what we see from our customers, especially once the pandemic hit, was this need to now use your PC to interact with everyone else, right? And so now all of a sudden everybody was on camera, everybody was using their PC to have all of these Zoom and Teams calls. And so bringing AI into the PC is helping to improve those experiences. And so you're using it every day, whether you realize it or not, it's there in your PC. And I think one of the challenges that you were asking, why is it so hard? And to your point about most of it being in the cloud today. So again, like trying to do those trainings for the models, like there's a report that the Stanford Institute did that talked about the energy required to train the Copilot or ChatGPT model was on the order of 500 metric tons of carbon. And so that's like the equivalent of powering over 200 homes for a year. And so you can think of how do we bring that kind of model or that kind of AI into the PC? We have to drastically then scale. We need everybody who's creating these models to help optimize them, and so we can have more AI experiences in the PC.
Great. And then, is there anyone that you have seen do that better than others? And is there anything that you would recommend anybody in the room? Is like, well, here's what I've seen somebody, they kind of did it themselves, or they went to a class, or they did something. Any kind of better practices that you have seen on people adopting it?
I think definitely we're working with all of our hardware and software partners, NVIDIA included. And every partner is trying to dedicate compute space within the silicon for this purpose. And also on the software side, trying to develop these experiences for customers. I think that it's not there yet. We still have a long way to go to optimize hardware and software together to have the a better experience.
And I think that, again, going back to the human factor is as important as the technology factor when you're bringing them together to actually solve real world problems. Okay, so I want to make sure that you guys are preparing your questions because I'm about to get you in 5 minutes, but I want to cover a couple more topics on the stack of AI and specifically the hardware element of it. Economics of AI. So I started this conversation saying, okay, well, so for anybody in the room, your NVIDIA bill used to be X, and that NVIDIA bill is now 5X. Whose budget in the room has gone up by 500%? Yeah, I thought so. So that means that we're taking money of our budgets to put into this thing that we think that is really important, and that means we've got to take it from somewhere else. And I think some people in this room are starting to do that math and not liking it a lot, because up until now was about like the magic tricks and everything is very sexy and let's go after all of these things and AI is free. Like literally, I think for the last 6 months, the world has presumed that AI is free. You just like, I mean, not free, maybe $19 a month. But now that $19 a month is becoming 90 million a year, and it's like, whoa, 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 whoa. Who's gonna pay for this? So I'd love to get the three of you give a reflection on the economics of AI and saying, at some point, somebody has to pay these bills, and we have a lot of hope for productivity, but that means until we get that productivity, somebody else is gonna be shortchanged. What are you seeing about that, and what's your view? Obviously, you know, I'll start with NVIDIA, because since you do want them to pay your bills, I figure you have a pretty good argument. So who in society and business is gonna pay this, you know, I mean, and that's just hardware. Then you put all the money going to venture capital, all the money going to software, the nose-bleeding valuations that go into those. So it's not 100 billion, you probably get to the 500 billion. Like who's gonna come up with 500 billion in the economy at a GDP that is not necessarily kind of like creating that sort of money? What's your view, Chris?
I think it's a fair question, but maybe the comment I made at the beginning informs my opinion, and I'll speak for myself, not for NVIDIA in this, right? So anytime you've looked at the beginning of some industrial revolution or some big thing, right, there's the opportunity to invest in a potential you see that's coming ahead. So to the point that was made a minute ago about for example, the amount of energy and effort goes into training a model, right? You need the infrastructure. In fact, if a few of us got together and said, hey, we want to start an AI business today, or we said we're going to go work with IBM Consulting to do something with one of you, right? I would say there's 4 things that any AI application or AI work leverages these 4 things, right? It's a hardware stack. It's the GPUs and the things we mentioned a minute ago. Could be on premises in a data center in the cloud. It's a software and tools piece we just talked a little bit about as well. It's data, right? It's the pieces of data that go into training a model, and then it's the human expertise that leverages all those things to create. The data piece and the models piece goes back to this investment. My observation right now is there's a handful of companies who are doing the many millions of dollar investments into creating models, and then there's a whole pile of people around that who are leveraging that work and integrating that into their applications and things. So I think what we see, to your question, is an investment toward markets that are just barely emerging for the first time. So if you listen, and I can say this, from NVIDIA's perspective, Jensen, our CEO, had a phrase he used quite often, which kind of got everybody laughing when he said it because of how often he said it. And he would say, in explaining the increased work capacity that can be done by a GPU relative to something else. So when he was talking about hardware, he would say, the more you buy, the more you save, because even though this is more expensive per unit, it can do more than the alternative. And what we've seen pretty quickly in this last year or so, right, to your point about budgets, a year and a half ago when ChatGPT kind of opened everybody's eyes, nobody had budgeted in that year in 2024 or 2023 for a whole bunch of AI research and development. But people quickly said, we've got to find a way to jump on this opportunity or get left behind in some sense. And so this year and next year, those budgets are opening up because the opportunity is being seen. So Jensen's, we've actually watched new businesses start from scratch for this purpose all over the place. And Jensen now says, the more you buy, the more you make. AI is opening opportunities. I mean, how many, 400 people here, 300 people here? There's potential for 400 new businesses tomorrow, leveraging the technology that's open here. And we'll see markets and we'll see, the increase in the funding for this explode, I'm confident, over the years to come.
Yeah, I'm hoping you take credit cards.
I am not in the payments process at all.
Prasanna, your view on this is, again, it's like there is a lot of, I don't want to call it hype, but unusual expectation of a rather significant creation of value, but is time shifted to the time that you have to pay all these AI bills. How do you see this kind of like regulating itself? Who's, again, the question is, who's going to pay all these bills up until we get the productivity?
Yeah, I mean, we're also in the consulting business, so we see a lot of enterprise clients, but we also look at kind of the private equity side and the venture capital side, looking at living in Silicon Valley and being owned by a private equity firm. We kind of get a sense of those, or we're a public company, but previously owned by a private equity firm. I divide it into kind of 3 economic models that justify the spend today. One is a private equity style model, which basically says I can leverage AI to reduce my operational expenses, and therefore my multiple is going to increase, and I can sell this company at a higher multiple than what I bought it at. And so that's purely an OpEx optimization play. On the other extreme is the VC play, which is saying that I'm going to imagine a completely new world where all the things that you've done in the past are maybe not as relevant, and that there's a completely new way to do things, and I want to get a monopoly of doing one thing as fast as I can. So it's speed to monopoly type of an argument in the VC space, and that is driving the justification for money going in. And enterprises typically are kind of in the middle. One part of the enterprise is going to ask, hey, what is your short-term ROI in terms of cost savings? And the other part is going to say, but where are we going in the long term? Is this really a market we want to be in? What does the future look like? So enterprises essentially are either you can look at it as stuck in the middle or have opportunities on both sides of that, depending on kind of where they are, where they want to play. And that's, to me, has been the justification for the spend. So if you look at industries that are used to making large capital outlays with risk, like pharmaceutical industry, they're willing to say, okay, instead of buying a wet lab, I'm going to buy GPUs, and I will wait for a few years. Maybe something will come out of it, maybe it won't. So they're willing to take some bets. Other industries are much more operationally focused and saying, show me cost savings in the next 3 months, otherwise I'm going to defund this. So it's somewhere on that spectrum. People are choosing different economic cases.
So I'd say those of you using AI start working on those business cases, because otherwise it's going to be tough to get the money for the budgets, right?
Yes.
And your view?
I think we're already there. There's many surveys out there, and to Chris's point, there's companies wanting to invest now. They see the opportunity, willing to spend a couple $100s on having AI put into their workforce. I think one of the examples we brainstormed around was like, what is the biggest pain point in your day that could improve with AI your productivity? And it was like just getting started on a PowerPoint presentation. Like how many of you kind of procrastinate getting started on the PowerPoint because you just don't know where to start, right? But with AI coming in, like it can summarize, it can look at your hard drive, it can summarize all the documents you have and get you started. And that right there is a productivity improvement, right? Whether it be an hour or 3 hours, right? That right there is the real impact to our daily productivity. And so I think, yeah, we're there already on trying to invest.
And I think the unsaid part of that answer is, see, if we just get people to do PowerPoints faster and take longer lunches, the company saves $0. So they still don't have money to pay for that bill. The only way that the company gets to pay for that bill is if instead of needing 10 people, they need 5 people.
We need 5 people.
So what are your views on that? Is again, this idea of, you see, this conversation with CFOs goes very different than the conversation with the heads of innovation. Because the head of innovation say, I can make everybody 10% more productive. And the CFO says, and how many FTEs have you reduced?
Sure. But those same 10 people could perhaps do 30% more innovation and bring additional revenue into the
So
company.
it requires growth. So it's shifting the productivity. First, you have to realize the productivity, then shifting that productivity to growth, and then that growth has to create enough value to pay for this, which is why I told Chris, you better take credit cards, because it's going to take a while to get there. Right?
Can I add just a comment? I get to watch this happen day to day. My day-to-day work right now is largely working with some of our largest software partners, right, in applications that are used across industries and across the world. And it's the sequence that you just described is almost the path that everybody has followed for the last 18 months. It is, let's understand what AI is capable of doing, and often we'll do that in an internal kind of optimization type of use case, right? I'll save somebody money, I'll speed up somebody's time. And that learning is leveraged then as they look at the innovation that's outward facing, that's growth minded, that impacts their business. So there's a bit of savings first as you kind of get your feet wet, and then it's the real impact comes with the growth that follows.
Yeah.
And that path has happened again and again.
Yeah, and I think I keep staying on this is because we have recent history. History doesn't necessarily need to repeat, but it should teach us. 5 years ago, we would probably be having a panel here about climate change and sustainability and how many trillions of dollars we're going to put on sustainability because we need to save the planet. And as a CEO put it to me, the first bullet point on sustainability needs to be economic sustainability, because otherwise it won't last. And that has actually happened. So now the word sustainability is a little bit more loaded. The term ESG is being eliminated of proxies as quickly as you can make it disappear. And then everybody's more thoughtful of saying, well, wait a minute, yes, we do need to do something about the climate. It is existential, but it needs to be done in the context of making it economically viable. If we kill the company in the process of like trying to restore the planet, well, we get either of them done. I think there is some of that adult discussion on the AI space to de-hype it, right? To make sure that we do focus on the clear productivity improvements that create enough value that can sustain the multi-year funding of this journey versus kind of like the sugar rush of like, you know, one of these things. And I think this is an important conversation that I think in most panels on AI is never touched because it's inconvenient, right? It doesn't fit the narrative of like, everything is so great with AI, which I thought it was appropriate to handle. Last thing before we open for questions. Another one of the choke points where hardware has a very, very big responsibility to solve is energy consumption. And this is my favorite topic, by the way. My other passion is neuroscience. So speaking of hardware, we actually have a pretty good AI hardware ourselves. It's called the human brain. It consumes 12 watts. I mean, some of you guys are smarter, so maybe you get to 20 watts. But you know, mine is probably average, so 12 watts is it. I just took the statistics of like on average. What did it take to actually train GPT-4? You probably know it very well. It was done on 10,000 V100s for roughly 150 days nonstop. So I did the math, right? That's basically 7,200 megawatts hour compared to my 12 watts. That's pretty much, well, actually, I'm going to do another compare, right? So an average brain has roughly 100 billion neurons and 100 trillion connections, roughly. let's abuse the language and assume that a connection is a token, which is a pretty bold like confusion, but it's convenient for my story, which is so GPT-4 is 1,000 times less powerful than my hardware in the human brain, and is consuming 1,000 times more energy. So it's off by 1 million, by a factor of 1 million, right? By 6 orders of magnitude. The hopeful would say, wow, we have a lot of room for improvement. So what are you guys seeing? Because this is gonna be a constraint. By 2026, just AI workloads will consume more electricity than the entire country of Denmark. We are gonna choke it, right? We're gonna choke point the whole thing. So what is the optimistic view is, I know that all of you guys are working on much more efficient hardware, but making it twice as efficient ain't gonna cut it when you're off by a factor of like 1,000 to 1 million, right? So any views on that?
Sir?
I'll start.
Yes, I do.
I can give you my view.
So
Prasad, I know you have views.
I have views. I think anything that takes GPUs away from Bitcoin mining is probably a good thing. So that's one thing. But the other side of it, yeah, absolutely, I think this is the question. We have one project we're working on. It's called the Square Kilometer Array, which is the world's largest radio telescope, which based out of Australia and South Africa. And as a part of that, for the AI processing, the government of South Africa has given a power budget. I don't remember exactly the number, but it was 100x off from what any technology can handle at the time that this project started, which was about 6, 7 years ago. And so what we've been working on is essentially designing custom chips, which are purpose-made for a particular type of an algorithm that can then perform that particular algorithm within the power budget. Which is kind of a way of saying you're sacrificing generality for efficiency. The same thing applies with cost as well. I think when you have something that's very general, can solve any problem, it tends to be more expensive. When you make it very specific, it only solves this one algorithm, but it can do it 100 times, that thing can do it cheaper. So I think if you're in the explore world, typically you end up having more general cases, but at some point, once you know you want to exploit this particular thing, you can. There are some ways to improve the efficiency. The challenge is not 1 million times more efficient
Not
someday.
Yet. Not yet, right?
yet.
Yeah, I think everyone recognizes the problem. We see many different partners trying to optimize and then have the dedicated compute at the edge so that you're not using that cloud power all the time. But it comes back to, yes, there are trade-offs in accuracy and latency. And so it becomes a question of, well, are you willing to trade that off to keep using it?
Yeah.
And maybe that experience of trading off accuracy and latency is not worth it to you, and so you stop using the feature. I think that's the risk, right? We need to be able to get to that point.
I think you're right. Engineering those trade-offs is going to be, I mean, sometimes if you can get 90% of the output with 10 times less parameters or 10 times a smaller model, that is going to consume 10 times less energy.
Right.
Well, that's a trade-off worth making, right? And I think engineering those trade-offs is something that is going to be on us to make
Right.
sure that we do that. I'd love to open for questions before we run out of time. I don't know if
You
anybody.
skipped the NVIDIA perspective on that. I know.
Yeah. Any, I cannot see with the light. Any hand up? Otherwise, I'll keep making up questions.
She has a question.
I'm here.
Oh, sorry, I couldn't see you.
You're good.
I have like this flashlight on my face, so
I know.
it's all like blurry.
Jesus, thank you for hosting this panel. Super interesting discussion. I know we're super short on time, so I'm going to be very brief with my question. Going back to Chris, your point on data and quality of data, how are you assessing perhaps your clients and customers on the importance of cleaning data before implementing any LLM? What's your take on that? Thank you.
Yeah.
Who wants to pick that up?
Start with them.
Yeah, happy to answer. In fact, it touches on my thoughts of your last question. In one part in particular, one of the areas you use the data around, or the numbers around training GPT-4, right? Massive model, and I think one of the things we've seen is that there will be a relative few people who train the models at that size, and most applications and most enterprises will take those and then customize them, and that work is much less.
Yeah.
So that's relevant there. And to the point, whether you're training something from scratch, your Google, your Meta, your NVIDIA, or someone else, or you're doing optimization of an existing model, the question implies that a correct observation. Having the data prepared is super important. And so even as we've done that internally for our own research, our own development, things we've been making available to the ecosystem, we've developed tools. That's the innovation that happens at NVIDIA is usually by things we're doing ourselves initially. We've developed tools for curating data, for cleaning data, and then we've been making those available to the ecosystem as well. So the first step, if anybody is, we're going to start 400 companies tomorrow. If anybody's starting that company and is going to do either training or customization of a model for this, just assume step one is data preparation, and that's an important piece.
Thank you, Chris. And I forgot to introduce myself. My name is Ana Aristizabal from Colombia. I'm very happy to be here. Thank you.
Awesome. We have one more question, and then we're going to wrap up.
Slay from Hewlett Packard Enterprise. Can you hear me now?
Oh, thank you for hosting us.
Yeah, of course, it was all me, no. So my question actually kind of follows up with the question that was just asked. So of course, data is foundational for AI, but how much should we spend on training the models versus actually impacting the human mindset, which is what's creating that data?
Yeah, I can.
Prasanth, you want to take that one?
Yeah, so we're seeing AI readiness as a thing that a lot of clients are interested in. And it has kind of three dimensions. One of them is data, one of them is people, and the other is infrastructure. So I think it's very, we're seeing a wide spectrum of challenges in terms of people, because I think the first question is, when you want to bring in AI, does that mean I'm going to be fired? Like that's kind of the first thing, and so there's
The answer is no, by the way.
Yeah, I mean, I think but that does, whether people say it out loud or not, I think part of how you communicate, part of how you create excitement about a program kind of starts with how this is going to make your job easier. It's going to take up the mundane work, let you do more creative activities, and so on. So I think the people aspect of it is very critical, because so when you talk about why have so many AIs not gone into production, one pillar of that is because people look at it and go, A, I don't know how to use it, or B, I see this as a threat and I'm going to resist it. So I think part of it is how we manage the change management aspect of this is absolutely critical.
And I think with that, and slightly over time and a flashing red light on me right now, I would like to thank Ann Viegas, Prasanth Pence, and Chris Nelson. Thank you very much for helping us better understand AI hardware.
Thank you, Jesus.